way back at the beginning, pre-philosophy, pre-Plato, who formulated philosophy as a systematic, comprehensive view, human conceptual view on reality. People have had wisdom for a long time in all kinds of different places, but he developed philosophy, a systematic, integrated, comprehensive presentation of it. But before that, we had, before Plato and his tradition, influenced by the Middle East and Egypt especially, the ancient Greeks, more culture there. Egypt, Mesopotamia, Babylonia, other places were more like Europe was primitive at the time. Not much there. So before Plato, after Thales, was Pythagoras, a name a lot of us know from Pythagorean theorem. But they thought math was everywhere. It was the essence of things. It was like the Thales, I'm referring to Thalesian, I guess I should say. It would be like maybe a one in the many in his program, in the Greek program. It unified things. It was like gave a basic ratio that we use to compare other things, so to speak. Reason, ratio, comparison by numbers. And they thought math was everywhere. And interesting that after philosophy and human wisdom and thought developed more, we developed through Plato and Aristotle, and scientists who did science and had to serve as some epistemologists like Galileo and Kepler and Newton and Darwin and others, especially 1500s, 1700s. With that, those achievements in human history, that achievement of thought, the development of thought, development of science, we got a broader perspective. Pythagoras didn't have much to go on at the time. Now we got a lot more. And some of this has been crystallized in some work of Rand, where she's a new Pythagorean, so to speak. In many ways different. I just mean in terms of the math and some epistemology there. Pythagoreans thought to know the universe, we had to know math, because math was in everything. And Galileo, Kepler, Newton, others, James Clerk Maxwell, used it to identify the nature of things and cause-effect relationships and develop science. We could use math to measure, to compare things, to classify, to identify cause-effect relationships. It opened up new realms. It was this new epistemological development. It allows us to know and classify the moon and a rock as being the same kind of thing. They're both falling objects around the earth. It allows us to see that electricity and magnetism are different aspects of the same thing. It allowed us to see that different colors of light had different wavelengths. Gave us this power to know and understand. So it's like the Aggie joke, or it could be a Longhorn joke or whatever. Being in Texas and having gone to University of Texas, I'm going to call it an Aggie joke. From my brothers at Texas A&M. But one day, an Aggie went to the doctor. He said, "Doctor, I'm hurting all over. Every part of my body hurts. It's like I touch my head. Oh, it hurts. Gah!" I touch my nose. God, it hurts so bad. God. I touch my elbow. Oh, God, it hurts so bad. I touch my foot. Oh, God, it hurts so bad. Doctor, what's wrong with me? I'm falling apart. And the doctor says, your finger's broken. It's in the finger, not in everything. Math is in us, not in things. Just like we had to go through and correct some things people have had, not we, but people, thankfully for us, they've gone through and they've corrected some mistakes. Like Plato, at his period of time, being a genius, but still being wrong on a lot of things, thought the one in the many, the essence was in some spiritual realm floating. It was like another thing. Instead of a concrete perceptual thing that changed everything, with this non-material, mental, spiritual, like in terms of non-material, thing that was the form of hoarseness, or the form of pancakeness, or the form of two, the perfect triangle, perfect justice, perfect honesty. And supposedly that's how we'd know the reflections in the world, the shadows, for Plato. Aristotle got things right. Another genius, two geniuses in a row, thank goodness. One got things right. No, the essence is in things. It's perceptual. That's where the essence is. So he made it real, but still some mistake there. And then Rand identifies, no, it's in our minds. It's an integration of things in the world. And so it's like getting Aristotle and Plato and correcting them. It is mental, it is not metaphysical, but it is epistemological. So for Plato, it would be metaphysical. It's this thing out there, but it's still mental. And Rand identified, oh, it's mental, but it's epistemological. It's in us. So Aristotle was right that we get it from perception by a process of abstraction, but it's epistemological. It's in consciousness, in our minds, something we identify as similarity. But there's some other things that were going on, and that's similar to this with math. So for the Pythagoreans, math was something in the world, and Rand identified it was something in our minds. It was our way of knowing. So to develop that. Internet Encyclopedia of Philosophy. A nice, good source. And the Stanford Encyclopedia of Philosophy is another good one. But here, there's a part about Pythagoras. So it says, Pythagoras of Samos, 570 to 490 BC, around there. With Pythagoras and the Pythagoreans, a new way of thinking was born in ancient philosophy and had a significant impact on Platonic thought, unquote, and others. So, quote again, Plato and Aristotle tended to associate the holiness and wisdom of number, and along with this, harmony and music, with the Pythagoreans. For example, the decad was sacred. The Tetractes shows us the holiness of the number 10, unquote. So, decad, D-E-C-A-D. I'll put a link, definition, just means 10, like 10 things. Not so much the number 10, they might have meant something different by it, because we need to remember, math is a different conception for us than it was for the Pythagoreans. We have a more abstract view of it. I think the Pythagoreans seem to identify number with things as such. It was not so much of a distinction between an idea and a thing, because some development of that came later, like them and Plato, especially Plato, identified a lot of differences between concepts and percepts. which some of which he got from people from before and all that. He's systematized and everything. But, and I think it's how you pronounce it, Tetractes. That's how I've heard it so far. Could be wrong, but I'll put a link to that too. Put it in the description field so you can go look and see how it's spelled. But in here, and then you can see in this, it's got a diagram, 10 things made into a triangle. That's the Tetrades, if you pronounce it like that. The Tetrades shows us the holiness of the number 10. Quote, here we can see a relationship among numbers, all of which leads us to a figure. There is the 1, which begets plurality 2. When we add 3 and 4 to these, then there is a sum of 10, which, where did I go? I'm recording on my phone. Phone call came through, recording and stopped. It's like my backup. Hopefully this works too. So I was wondering what was going on with that. So where were we? Okay, so quote, there's the 1, which begets plurality 2. When we add 3 and 4 to these, there is the sum of 10, which signifies the composition of the cosmos. There were 9 visible heavenly bodies, and so the Pythagoreans posited a 10th body, counter-Earth, to balance out the cosmos. Unquote. Because there's got to be 10. It's in our heads. Reality is to obey. Reality is to obey math. Quote, the Tetractes also gives us the ratio of harmony, 1 to 2, 2 to 3, 3 to 4. Or the octave, the 5th and the 4th, respectively. The universe's harmony, and Philolaus considered the soul also to be a harmony. Thus, at least for Philolaus, the soul could be considered to be a type of microcosm. Perhaps more basic than number, at least for Philolaus, are the concepts of the limited and unlimited. Nothing in the cosmos can be without limits, including knowledge. Imagine if nothing were limited, but matter were just an enormous heap or morass. Next, suppose that you are somehow able to gain a perspective of this morass. To do so, there must be some limit that gives you that perspective. Presumably, nothing at all could be known, at least not with any degree of precision, the most careful observation notwithstanding. Additionally, all known things have number, and number is classed in 2 kinds, odd and even. Number 2, TOO, can be seen here as a kind of limiter. Each thing is 1 and thus separates from other things, unquote. So, Pythagoras. They did some work in math, find it important, maybe prove the Pythagorean theorem, I don't know. But come on, record again. There. In Conjectures and Refutations, Karl Popper points out, listening to that, you get an idea of some more of the mistakes Karl Popper makes. Sad and unfortunate. Good, he's like wants science and wants to differentiate it, but his program is a failure. Unfortunate. But in there, he makes an interesting observation I'd never heard before. So much to learn, so little time. But when the Pythagoreans were dealing with things, working with dots to represent number. So remember, it's a different idea than us. It's not like they knew they were always dots, maybe, but pebbles, dots, you could still 2 and 3 and stuff, but the idea was just more closely associated with things than it might be for us. But then you can get, a 9, put a triangle with another triangle, and get a square. But Popper pointed out that this is some people like pointed out to him. It's like some stuff you read, I guess. It's like some of the stuff is like dots in the sky. It's like the constellations. What do you have for like a dipper? Some dots. And so I'm not sure if they actually did, but I could see how the Pythagoreans could identify a similarity. But they did think there was harmony in the heavens, and then hence we got the idea of the music of the spheres, if you've heard of that. If I remember, I'll put a link in the description field about that. I'll make a note to myself so I don't forget. Music of the spheres. Okay. So the Pythagoreans also discovered harmony as ratio. They're the ones that found that experimentally and developed it. Not experiment in the sense of today with the really refined, rigorous, developed concept coming out of Galileo and Newton and many other people. And refining the work of the alchemists into chemistry. And really refining it into being able to do work in biology and ecology and all that. But they did get an idea about music as being a harmony, and hence it was mathematical. So they thought math was in things. And then when there was a certain ratio among the heavenly bodies, and that would produce a harmony. And then they explained things like male hit a number, female hit a number, marriage hit a number, justice hit a number, because everything was essentially a number. But remember, it's a different concept, a little bit than for us. Number, harmony, some things hadn't been. It'd be like a different concept, a different connection of ideas. Just like physics, as we know it today, did not exist. If you studied knowledge or did anything, it was philosophy. It was a love of wisdom. A long time ago, before the subjects got separated, and Aristotle was instrumental in doing that, identifying the different subjects qua sciences in their own field, in their own premises and things, and really working that out formally and theoretically and epistemologically and logically, and not just doing it. All of it would just be wisdom or knowledge, like all the stuff that maybe like the priestly class in Egypt would do. They write, they read, they're scribes, they're astronomers, they're mathematicians, historians, just all together. And then now it's separate. So some of the stuff could all be that we've separated out because the people before us, not on our own, none of us do it ever, but because of what we've learned, we separate out some of these concepts. We got these refinements that we learn from other people in education. But then Aristotle does his work. Galileo grasps, and Kepler called his book A New Astronomy Based on Causes, not on mathematical nonsense made up out of nowhere. I mean, really, the Ptolemies didn't really do that, of course, but just to emphasize a point, it was dispensing with the material world. It was full of lies and illusions. We come up with ideas that are nice, and circles are cool, and so we use a bunch of circles because they're perfect to do astronomy, and could do some really complicated math. It was awesome. Got some ideas of orbits, but a lot of it was just trash. A lot of bad ideas, bad directions, and Copernicus had to shake things out and throw out all the bathwater and everything and keep the baby. And they used, as Galileo says, according to Aristotle, all human reasoning must be placed second to direct experience. Experience comes first, perception, we reason from that. Experience is a given. Then, bam, look what happened to science after that. It just rocketed off and took off because it had a solid foundation and people could think about it and communicate it and do it well and be logical. And then with this new, instead of just everything all being together as it was in Pythagoras' time, and not much had been developed. We didn't have Euclid yet, or Pythagoras didn't. Geometry was just starting. Euclid systematized all known geometry at the time, proved things on his own, and that's basically it's so well done and so perfect. That's what we use for geometry today still, because truth is truth, universal and timeless. From what I've heard, other people had done a systematization of geometry, but Euclid's was so much better. It's the one we know, and it's the one that's passed down to us. The others, I think, have been mentioned. I got to dig into it more. So much to do, so little time. But they were mentioned, but they're not known anymore. I don't know if there's any of them that are still extant, any of those books. But we got all this science to look at now. And so we can make some corrections given Aristotle's identifications and what science did. And so now we can see, what people identified and didn't really, what they used but didn't really identify explicitly, but Ayn Rand did in looking at what these people did. Math is our way of knowing things. So here about measurement. And I'll put a link to this. I don't know if I can copy and paste the whole thing. But, quote, measurement is the identification of a relationship. Unquote. It's in here. Quote, measurement is the identification of a relationship. A quantitative relationship established by means of a standard that serves as a unit, unquote. Now, measurement is a broader concept than mathematics. Mathematics is conceptual measurement where we start to count, do arithmetic, multiplication, algebra, calculus, all this stuff. We can measure and we do without math. The more and the less. We like one thing more than another, less than another. We know some things are further than other things. Some people are taller than others. We don't got to measure it and say 5 feet 3 inches versus 5 feet 5 inches or whatever. We can tell in perception by looking. It's a fact that one thing's bigger than another. Something's farther than another. In animals, the human animal and other animals can measure out how far to jump or whatever. You kind of measure out some importance. We measure and weigh and balance. But measurement is a broader idea, and math is conceptual measurement. So, quote, measurement is the identification of a relationship, a quantitative relationship established by means of a standard that serves as a unit. Entities and their actions are measured by their attributes, length, weight, velocity, etc. And the standard of measurement is a concretely specified unit representing the appropriate attribute, unquote. Then you're getting into math. Quote, thus, one measures length in inches, feet, and miles, weight in pounds, velocity by means of a given distance traversed in a given time, etc. It is important to note that while the choice of a given standard is optional, unquote, so like, is it an inch? Is it a mile? Is it a foot? Is it a meter? We got to have some standard, but what the standard is can vary. So, quote, it is important to note that while the choice of a given standard is optional, the mathematical rules of using it are not. It makes no difference whether one measures length in terms of feet or meters. The standard provides only the form of notation, not the substance nor the result of the process of measuring. The The facts established by measurement will be the same regardless of the particular standard used. The standard can neither alter nor affect them. The requirements of a standard of measurement are that it represent the appropriate attributes, that it be easily perceived by humans, and that, once chosen, it remain immutable and absolute whenever used. Please remember this. We will have reason to recall it. Now, what is the purpose of measurement? Observe that measurement consists of relating an easily perceivable unit to larger or smaller quantities, then to infinitely larger or infinitely smaller quantities, which are not directly perceivable by us, to man. The word infinitely is used here as a mathematical, not a metaphysical term. The purpose of measurement is to expand the range of man's consciousness, of his knowledge, beyond the perceptual level, beyond the direct power of his senses and the immediate concretes of any given moment. Man can perceive the length of 1 foot directly, but he cannot perceive 10 miles. By establishing the relationship of feet to miles, he can grasp and know any distance on Earth. By establishing the relationship of miles to light years, he can know the distances of galaxies. The process of measurement is a process of integrating an unlimited scale of knowledge to man's limited perceptual experience. A process of making the universe knowable by bringing it within the range of man's consciousness, by establishing its relationship to man. It is not an accident that man's earliest attempts at measurement, the evidence of which survives to this day, consisted of relating things to himself, as, for instance, taking the length of his foot as a standard length, or adopting the decimal system, which is supposed to have its origins in man's 10 fingers as units of counting, unquote. And there's more. And here, then talking about it, so there's measurement, and now in terms of concepts and thinking, and how this is in everything. So this is, in a way, in the Pythagorean tradition. Quote, observe the multiple role of measurements in the process of concept formation, unquote. You know, dog, justice, honesty, table, electricity, magnetism, synecdoche, literature, romantic literature, you know, in the sense of like non like dime store novels, but like Victor Hugo and all that. Quote, observe the multiple role of measurements in the process of concept formation in both of its two essential parts, differentiation and integration. Concepts cannot be formed at random. All concepts are formed by first differentiating two or more existence from other existence, unquote. Okay, so it's like Aristotle's process of abstraction. Unquote. All conceptual differentiations are made in terms of commensurable characteristics, i.e., characteristics possessing a common unit of measurement. No concept could be formed, for instance, by attempting to distinguish long objects from green objects. Incommensurable characteristics cannot be integrated into one unit. Tables, for instance, are first differentiated from chairs, beds, and other objects by means of the characteristic of shape, which is an attribute possessed by all the objects involved. Then, their particular kind of shape is set as the distinguishing characteristic of tables. A certain category of geometrical measurements of shape is specified. Then, within that category, the particular measurements of individual table shapes are omitted. And we get, unquote, and we get table. Process of abstraction. So it's a improved, modified, updated version of what Aristotle said in the process of abstraction. Quote, please note the fact that a given shape represents a certain category or set of geometrical measurements. Shape is an attribute. Differences of shape, whether cubes, spheres, cones, or any complex combinations, are a matter of differing measurements. Any shape can be reduced to or expressed by a set of figures in terms of linear measurement. When, in the process of concept formation, man observes that shape is a commensurable characteristic of certain objects, he does not have to measure all the shapes involved, nor even to know how to measure them. He merely has to observe the elements of similarity. Similarity is grasped perceptually. In observing it, a man is not and does not have to be aware of the fact that it involves a matter of measurement. It is a task of philosophy and of science to identify that fact. Unquote. So there we have math being used to know everything in a way, or measurement. Measurement, the broader concept. So we got things, these different things, different shape, in contrast to whether we form the concept of table. We leave aside the measurements. Then if we're going to study something and be scientific, we bring it back so we can do cause-effect. We can identify the nature of things and do cause-effect relationships. Identify cause-effect relationships. Like as what Galileo did with pendulums. How does the period of a pendulum vary with its length? How does the energy of some electromagnetic radiation vary with the frequency of the irradiation, or the wavelength of the radiation? Because frequency and wavelength are related. So we can see different colors, and people learn through history that you can get a prism and have the different colors and put a thermometer, and the thermometer will change at a different rate in the different color, red versus all that, through blue, red, green, blue, and all that. And even outside those, there's like thermometers are affected. Just because we can't see it doesn't mean there's nothing there. There's stuff beyond that. But we know that there's some heat being, like, the stuff in the thermometer is being heated up. And then people learn that, like James Joule does an experiment, does all this math, he's able to figure out motion causes heat. It is heat. It's like a change in temperature. We can drop a weight and turn a paddle wheel and know exactly how much energy there was in that dropping weight, take away the friction, know how much jostled up the water, how much jostling is correlated with how much heat. So we know that when we drop it, we know there's energy there. It's like potential energy, kinetic energy, and heat is a form of motion. It's temperature measures average kinetic energy. So we know that. And then we can go, whoa, if the thermometer is increasing, the light is making the average kinetic energy of the stuff increase. And it's different amounts. So we know there's some energy there based on the different, like, color of light. So it's based on frequency. So we're seeing, we see that, math is not in the thing, it's in our knowing. So we can go, again, we got red, yellow, green. Then we can measure it and see what is actually there and form cause-effect relationships when we relate that to other things. So we bring the math back at a higher level. We got experience. We form a concept that, for like people. We know we're human. Does human mean being a certain height? No. We know it's in a range of height. Does it mean having a certain length of hair? No. It's like all kinds of different hair lengths. Shaved, bald, real long hair. Different strength, different amounts, measures of wisdom, different measures of honesty, different measures of all kinds of things. All these measurements vary, but we know to be human, we're within a range on all these seemingly infinite dimensions. And then when we study things, we make it mathematical. We see what measurements were implicit in forming a concept that we didn't have to know, but were kind of implicit perceptually. We bring them back. So the measurement is in us. It is what we're using to know things. So we got a kind of renewal of Pythagoreanism, but done right. Math is not in things. as we've seen and as Rand has identified by looking at what scientists have done, math is in us. The pain is not everywhere, it's in the finger. When we look everywhere and think there's math everywhere, it's because it's in how we know. Peace.